The decomposition of dimethyl ether, which is based on this reaction, is a first-order process. The half-life of dimethyl ether is 2,165 seconds at 450 degrees Celsius. We're told that the reaction is carried out in a constant volume container and that the initial concentration of dimethyl ether in the container is 2 molar. The questions we're asked are, what is the concentration of dimethyl ether after 1 hour, and how much time is required before the concentration of dimethyl ether becomes 0.2 molar? So I'll call this question part A, and I'll address that first. So the first thing that I'm going to do is just set up the equation for a first order process. And that is that the concentration of A equals the initial concentration of A times e to the negative kt. And I did go over this derivation in another video. And for our situation, we're going to let A equal dimethyl ether. So now that we have our governing equation to solve these types of problems, we're going to use the information given, which is the half-life, to find our value of K. And what you'll see in a lot of problems, especially about kinetics, is that we're just trying to find this K value. So that's really important to do, and most of the time you're going to end up first solving for the K value before you can answer the question. So the fact that they give us T half-life will allow us to find K, because we know that at the half-life, which I'll just call T half, 50% of the initial concentration of A has been consumed. So at this time, we know that our concentration of A equals 0.5 times our concentration of A naught at T equals the half-life given. And so we can use this information to find K by plugging into our equation. So A, which is 0.5 A naught, equals the initial concentration of A times e to the negative k times T for the half-life. So for this kind of problem, we actually don't even need to know the initial concentration of A to find K, because it's just going to end up canceling. And then you can verify my calculations. I get K equals 0.00032 inverse seconds. So now that we have K, we can answer the first question. And that is to find the concentration of A, or the concentration of dimethyl ether, at T equals 1 hour. So a common mistake that students make is that they don't think about their unit conversions for this problem. So that's definitely something to keep in mind for the exam, because many students will leave time in hours when they just found K in terms of seconds, etc. So I'm going to quickly convert T to seconds. So we know that for every hour we have 60 minutes. For every minute we have 60 seconds. So 1 hour is 3,600 seconds. So now that I have that, I can plug into my equation that I found in step 1 here to find the concentration of A after 3,600 seconds. So the concentration of A equals the initial concentration of A, which in the problem statement we were given is 2 molar, times e to the negative k, which is 0.00032 inverse seconds, times 3,600 seconds. So I get that A equals 0.63 molar. And that is the concentration of dimethyl ether after 1 hour. So now we can move on to part B. And part B asks how much time is required before the concentration of dimethyl ether becomes 0.2 molar. So in our case now, we are solving for T. And a lot of these problems are just asking you different variations of the same thing. A lot of the times you have your governing equation, you solve for K, and then using what you know, for instance, the initial concentration, the final concentration, or time, they'll usually give you 2 out of the 3 of these things, you just solve for the other variable. So for part B, we're just taking our equation and solving for time. So we're given that A, the final concentration, is 0.2 molar. So we know that 0.2 molar equals the initial concentration of A, which is 2 molar, times e to the negative k times T. And we're just solving for T in this case. So I end up getting that T equals 7195.58 seconds. And again, if your answer choices are in hours, you have to go back and convert this to hours. So you can also verify this, but I end up getting that T is about 2 hours.